Okay, hey Megan, we're going to finish the second half of 2.5 notes. This is rational functions. Yesterday we basically just went over like domain and we went over vertical asymptotes. So I'm going to put a little star right here. How do you find a va? I'm gonna say this. To find a va.
0 on the bottom.
Yeah, I set the denominator equal to 0 to find the va, okay? Now, sometimes we have holes. And how do you know if it's a hole instead? Like here's, I'll just do an example down here. I'm gonna do an example. Yeah, let's say I have y equals x plus 3 over x squared minus 9. Okay. This function, if you want to put this example down onto the side right next to horizontal asymptotes, this is a good example of ha's and vas, or holes and vas. This guy, if I set the denominator equal to 0, like x squared minus 9, if I set him equal to 0, x squared minus 9 is a difference of squares, right? The square root of x squared is x. The square root of 9 is 3. One of them is plus, one of them is minus, right? Okay. If I set those equal to 0, x is equal to negative 3 and x is equal to positive 3, right? And it looks like those are vas, right? A va and a va. So I have two vas. Except for, which one is a hole? The left one or the right one?
Right.
The left one. The x plus 3 cancels, right? So that means this guy is not a va, he's actually a hole. Now the confusing part, are you watching this? The confusing part is that this is x plus 3, right? Which means x equals negative 3 is the hole, right? If x plus 3 cancels, negative 3 is the one that's the hole. Got it? So you have to be careful because sometimes it looks like a va, but it's actually a hole, and you have to see which one cancels. So we do have a va. The va is at 3, but the hole is at negative 3. Okay, so hole looks like a va, but cancels with the numerator. I'll say numerator. Okay, so a hole looks like a va, but it cancels with the numerator. So we have vas and we have holes. We know how to find those. Okay. All right, next thing is a horizontal asymptote. So we have vas and we have holes. Now we need horizontal asymptotes. There are rules for horizontal asymptotes. Okay, here's what horizontal asymptotes look like. It's a horizontal line that he is approaching either from the top side or the bottom side, or going forever to the right, the top side or the bottom side. Do you see what I mean by top side, bottom side? Like approaching on the top side of the line or the bottom side of the line. Those are horizontal asymptotes. Here's the rule. Go to the next page. Here is the rule. Oh, I'm going to choke to death. The rule says this, okay? Yeah, I do need a sip of water. I need to blow my nose again. I got a lot of goop. All right. Okay. First example. Put this next to example 1. I'm going to give you 3 examples. Whoop, whoop, whoop. Y equals, let's say I have x squared over 3x plus 1. Man, oh man. Then I'm going to go y equals x squared over 3m x cubed plus 1. And then I'm going to go y equals x squared over 3x squared plus 1. Okay. Just changing it ever so slightly. Okay, those are my 3 examples. Write those down and we'll talk about them. We have to figure out where the horizontal asymptotes are located. And there's 3 rules, and they're really easy, but here's how you memorize them.
The 1, 2, 3.
What do you mean? Yes, they do match up with the 1, 2, 3. Yep, correct. Okay, here's why. All right, you ready? We are looking for what's called N and M. okay? For each one of these, we look for n and m for horizontal asymptote. N and m, okay? N is the degree of the numerator. It's the top. M is the degree of the denominator, like the highest power, right? The highest power of the top and the highest power of the bottom. Okay, that's pretty easy. All right, I'm going to explain this so that it's very easy for you to remember these. Ready? If n is the highest power of the top, the degree, what is n for this problem? 2. What's m for this problem? 1. He's 2 and he's a 1, right? Okay, so n is 2 and m is 1. And here's how you remember. Ready? 2 is bigger than 1. He is top heavy, and top heavy things fall over, right? Yeah? Top heavy things fall over. So there is no horizontal asymptote. He does not have a horizontal line that he approaches. So there is none here. No ha. Okay? All right, this one. What is his n? 2. What is his m? 3. The power is there, okay? He is bottom heavy. And things that are bottom heavy just sit there, right? The horizontal asymptote for a normal function just is at 0 already. So because he's bottom heavy, he's just going to sit there and he's not going to move. He's going to stay at 0. Y equals 0 is your horizontal asymptote. Like he looks like this. This guy, this dotted line right here. Because he's bottom heavy, he just sits down at 0 and he doesn't move. He stays at that horizontal line, okay? Now this guy, if n, what's n for this one, by the way? 2. And what's m?
2.
Also 2, okay? So when they are equal to each other, you look at the numbers in front, the leading coefficient. Okay, what's the leading coefficient right here? 1. What's the leading coefficient at the bottom? 3. So the horizontal asymptote is at y equals 1/3. Okay, so he looks like this. And if here's 1, my horizontal asymptote's like right there. Okay, does this make sense? If he's bottom heavy, he sits at 0. If he's top heavy, he falls over, so there's none. If they're the same, you look at the numbers in front. Okay? This is like not too bad. Okay? There's not even really any math involved for finding a ha. Got it? Okay, example 4. All right. Find the horizontal asymptote, if any, because there could be none, right? For the given functions. Okay, so we just have to find what n is and what m is. What is n? 2. What's m? 4. He is bottom heavy, so he's going to sit at 0. Y equals 0. It's that horizontal line at 0. Boom. Okay? B. Am I going too fast?
No.
B, what is n for B? 3. What is m for B? 2. So he's top heavy, so he's going to fall over, and there is no horizontal asymptote. You can put none or no ha. He's top heavy, he falls over. Okay, C, n is how much? 2. Does it matter that there's an x here? No. He's just like the highest power, right? Did you say,
I said
nah? Okay. And the bottom, m is 2 also, so I look at the leading coefficients. What's the leading coefficient?
8 and 2.
8 and 2?
Which is 4.
So y equals 4 is where his ha will be. And so just so you know, when we go to graph him, that means my horizontal line is at 4. Boop, 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 boop. He does that, right? That's what he looks like. Got it? Okay, not too bad, right? We like those.
Can you give our whole test those?
Our whole test be those. Okay. Yeah. Good, good, good. Good, good, good. Good, good, good. Good, good, good. Yep. Okay. All right. Now, example 5. This is where the weird thing comes into play just a little bit. Just a little bit, okay? All right. Are you with me? This is where the weird thing comes into play. Okay, a lot of people think that a horizontal asymptote is similar to a vertical asymptote. A vertical asymptote looks like this guy, right? And your function will look probably something like this, and your lines, your graph, will not touch that vertical asymptote. Never, never, never. Never, 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 okay? But if it is a horizontal asymptote, that doesn't necessarily mean your graph won't touch it, okay? For example, I could have a horizontal asymptote here, and this is what happens. This is what my function looks like. This is like legit a function. Whoop. Have you ever seen one of these before? Okay, where he like goes down and then he's approaching like 0 on the ends, right? Like he's flattening out. But this thing is crossing right here, right? Like it's actually touching the horizontal asymptote right there. Like he is allowed to touch a horizontal asymptote. It's just that on the left and the right side, he's kind of like leveling off at that point. Does that make sense? Okay. So this thing says, here is my function. Determine the point where the graph crosses the horizontal asymptote. Blech. Determine where it crosses the horizontal asymptote. So let's figure out where the horizontal asymptote is, right? Okay. If I'm looking at this thing,
4.
n is 2, m is 2,
4.
which means 8 over 2, which means y equals 4, right? It's the same equation as what we did before, right? The horizontal asymptote is at 4. I want to know where this function touches 4. Okay, well, I'm just going to take y, I'm going to take 4 and plug it in for y and solve for x, right? Where is he touching 4? Okay, right, we said y equals 4, that's the horizontal asymptote. I'm going to figure out where y is 4, okay? So if I'm doing that, I just have to do a bunch of algebra. 4 is equal to 8x squared plus 9x minus 5. I'm just recopying this down. 2x squared plus 1. Now I have to figure out how to solve this thing. What do I do first?
Complex triangle.
Yes, kind of. I don't like fractions, so how do we get rid of fraction?
Multiply it over.
Yeah, let's multiply it over. 2x squared plus 1. Boop. Gone. Times 2x squared plus 1. Boop. Okay. There he is. All right. What's on the left now? 8x squared plus 4. Got it. Here is, oh man, 8x squared plus 9x minus 5. I like this problem. Do you know why you like this problem?
It's gonna
Ha! 8x squared cancels. Boop. Gone. So I have 4 equals
9x minus 5.
9x minus 5. This is really nice. Yeah, and then I'm going to add the 5 over, right? 4 times 5 is 9 equals 9x, and x equals 1. So what I have happening here is, where was my horizontal asymptote again?
4.
1, 2, 3, 4. He's like this. And I possibly, at 1 is where he's touching, right? He's touching right here. So I probably have something maybe going on like this. Right? Where he's crossing through at 1. Does that make sense? Okay? So just because he's a ha doesn't mean I still can't touch. If you have a va, your function will never touch your va.
Wait, so is he
But-
touching at 4? 1?
He's touching at the x coordinate of 1, but he's touching the ha that is at 4.
Okay.
So he's touching the ha, which is at 4, at an x coordinate of 1.
Okay.
Yeah. So like this guy right here. Yep. Make sense? Good? So all we did was find the ha, and then we plugged 4 in for the y coordinate and solve for x. Beautiful, beautiful. Not too bad.
If
Okay?
it stays like this, then
Yeah.
It's not going
it's
to.
not going to, though.
And now. And now. And now. There's one last thing, and it's called a slant asymptote, and he is my least favorite of all, right? Okay? So let's discuss again. We have a va, a vertical asymptote, where you set the denominator equal to 0. We have a ha. How do we find ha's again?
The M and the N.
Look at n and m. Right? And then we have slant asymptotes. I'm going to say slant A. Here's how you find a slant asymptote. For the slant asymptote, you do long division. Okay? All right, here's what a slant asymptote looks like. Usually a slant asymptote will be in conjunction with a va. You will never have a slant asymptote and a ha at the same time. Never, never, never. And I'll show you why here in a second. But a slant asymptote might go like this. And then I don't know if you've seen functions that look like this before, but he looks kind of like one of these. Okay, so you have a slant asymptote. A slant asymptote is a linear function, right? It's just at an angle. And then you have your vertical asymptote, and he's like squeezed in. Sometimes he's squeezed in like this. And he looks like a Hurley. Like in Hurley H. Right? Does that look like a Hurley H? You guys know what Hurley is? No? Yeah. Does that look like a Hurley kind of. The blue, early H, kind of, whatever. Okay, so something like that. All right. Yay, perfect. You are awesome. Thank you so much. Thank you so much.
Please not have a final.
I don't think that's gonna work.
It will work great. We'll do anything.
We will clean your house.
We will.
I don't think so.
No,
Whoa,
actually,
whoa, who is
We
we?
will wash the outside.
No, you can
I don't
then
think
you
so.
can take the final and we'll do everything.
I don't think so.
Okay.
All right.
We'll babysit your kids for 3 days straight.
I don't know about that. Okay. All right. Slant asymptotes. You will have a slant asymptote when n equals 1 degree more than m. That's when you will have a slant asymptote. If that is not the case, then you will not have a slant asymptote. So, for example, we have, like, let's say x to the 4th plus 5 over x to the 3rd plus 7. Will I have a slant asymptote? Yes. Now will I have a slant asymptote? No, I will have a horizontal asymptote. Where's the horizontal asymptote? N is 4, M is 4. What's the horizontal asymptote at? 1, because the coefficients are 1, right? Okay. So you will only ever have a slant when this guy is 1 larger than that guy. Okay. So example 6. Is this guy 1 larger than this guy?
Yes.
Yes, so I will have a slant asymptote. Determine the asymptotes. Oh, by the way. Okay, N is 2 and M is 1. Will he have a ha? No, because he will fall over. He's top heavy, right? So he has no ha. Okay?
No.
All right. Will he have a va? How do you find a va?
Denominator.
Denominator equal to 0. Okay? My denominator is x minus 2. If I set him equal to 0, x equals positive 2 is my va. So I have a function that looks like this. 1, 2. And he has a va right here. Okay, that's what I have so far. Now I have to look for a slant asymptote. Okay? And to do a slant asymptote, I have to do long division, which is kind of a pain in the tush. But it's not terribly bad. So here we go. I'm going to do long division. The stuff on the top, this, because, right, a fraction is like division, right? Like, this is saying this guy divided by that guy, right? That's essentially what that says. Okay? So I'm going to put 2x squared minus 5x minus 3 inside, and I'm going to put x minus 2 on the outside. Okay. This is not that bad. This is not that bad. I'll show you what happens. Okay? We're going to do long division. What do you take times x? You get 2x squared. 2x, okay? If I multiply back through, 2x times x is 2x squared, but 2x times negative 2. Minus 4x, and then I switch my sides, right? Okay? This cancels. What's negative 5x plus 4x? Minus x, and then I drop my minus 3. And then I start over, right? What do you take times x to get negative x? Negative 1. So I'm going to multiply negative 1 back through. Negative 1 times x is negative x. Negative 1 times negative 2 is plus 2. Flip the signs. Plus, minus. X's cancel. My remainder is negative 5. So my remainder is negative 5 over x minus 2. And here is how you find the slant asymptote. All right, I just told you that a slant asymptote is a linear function, right? Like a line like that, probably, okay? We get to, as soon as we're done with the long division, are you listening to this? Cancel out your remainder. We don't even care about it.
Okay.
We could have stopped this long division function as soon as we got to the remainder. Your slant asymptote is only this first part. And your slant asymptote is y equals 2x minus 1. How do you graph y equals 2x minus 1? You start at negative 1, and you go up 2 over 1. Up 2 over 1. This is what my slant asymptote looks like. Okay? It's always just that first part. Yeah? Yeah, that's fine. Okay? So you don't use the remainder. It's only just that first part, y equals that. That's where your slant asymptote is. So if I graph this guy, 2x minus 1, I go up 2 over 1, up 2 over 1, etc., and he looks like, this, right? So either this function is here and here, or this function is here and here. One of those two things. And in order to figure out which one it is, I plot points and figure out which one he goes with. Good? We'll just say it's here and here. I don't know for sure. Yeah? That's a slant asymptote. Beautiful. Last one. Blah, 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 blah. Actually, example 7 we're not going to do. Okay? So, how do you find a va?
0 on the bottom.
Set the denominator equal to 0. How do you find a ha?
The N and
N.
Look for n and m. How do you find slant?
Long division.
Long division. When will you have a slant to asymptote? Only if
N is higher
N
than
is-
by 1.
1 higher. If n is 2 higher, look at this one. Will this guy have a slant asymptote? No, because it's 2 higher. It has to be 1 higher.
That's just,
That's not going to work.
that's a none.
That's a none.
But how do you find a hole?
How do you find a hole? If it cancels with the top and the bottom. So it looks like a va, but it cancels with the top and the bottom. Okay? So kind of 4 things happening. Vas, holes, ha's, and slants. There you go. That's all you need. 4. Yeah, the rest of it.
If I made a video about math, would that give me extra credit?
A video about math.
Yeah.
Does it have any intellectual stuff at all? You're going to be fine. This is going to be easy.
The final?
The final is easy.
You know what I have in this class?
The majority, okay, so Trig is my one class where, like, the majority of all of the kids get, like, at least a 95 on the final. You get 5 bonus points on the final, and you get your review on the final. This is going to be
Me
easy.
in math,
Easy peasy.
I'm good at everything else
Easy.
except math and physics.
Easy peasy. Easy peasy.
Yeah, not physics.
Like easier
Easy
than
peasy. Easy peasy. All right, I'm gonna shut it off. Bye, Megan.